Hello scholars, welcome back. Right now is Sunday night. What time is it? 8:30 at night. I just put my kids to bed, and I shoved my husband to room so I can have the dining room by myself recording this lesson. I just want to tell you guys that this has been a nice getaway for me time in terms of when I'm doing the schoolwork, just to be away from everything and just focus on math and just thinking about you guys. I'm just pretending all your faces are in front of me, which sounds crazy, but I'm picturing B1, you guys, awesome class, B2, awesome class, B3, awesome class, and I'm sure Mr. Bear will say B4, Riverside, awesome class too. I'm just, remembering all of your faces and all that. I miss saying hello to you guys when you're coming to the classroom and saying goodbye, walking around, creeping on your work behind you. And you're like, go away. I'm like, nope, I'm just looking at your work. And, I just really miss all of that. So, yeah. But anyhow, a few things I want to go over before I start the lesson today. Number one, you guys did awesome job. Skill 4041 assessment. I check every individual and I sent you guys the comment back, so you can check those by, I don't know how you guys do it, clicking on the email you got about those assessments. So check those. And number two, there are a few students telling me that I submit my homework, why am I getting 0, blah blah blah, because it's not on the Google form. So there are a few scenarios. You might have submitted to different class, you might have submitted to the previous skills. So make sure you're submitting it to the correct Google form. And the way you know it is when you submit it, you should get the copy of that confirmation to your email, and it should be same as what you submitted. So if you submitted skill 40 and a confirmation email say thanks for submitting skill 25, well, that means you did it wrong. So make sure resubmit it. I mean, worst case scenario, just email me. I can check it and all that. My class, you guys been doing really good job communicating with me, so I really appreciate it. Okay. All right, so today we're doing skill 44, logarithm. Notice that we did skill 40 and 41 and jumped to skill 44, and you might be wondering, what are you doing? Can you not do math? I can do math, guys. We are skipping a few skills here and there because we want to make sure that you guys are learning important skills before moving on to calculus next year. So that's what's happening here. Okay? All right, skill 44, understanding value of logarithm. Good news, logarithm, we covered that in algebra 2. Yeah, I did not talk to your algebra 2 teacher, but I'm pretty sure, 100% sure that you guys did it. So a lot of it is going to be review, but as we always say before, if you don't remember anything about logarithm from algebra 2, that's okay. We'll go over it together. All right, so the expression is a logarithm and is read, can you guys read it along with me? Log base b of a. Okay, so this is read as log base b of a. Then how would I read this expression right here? Log base 3 of 27. Log base 2 of 16. Log base 5 of 125. So this is like a language. You should know how to read it. I still have some students in calculus class read this as log 327. No. Log base 3 of 27. So make sure you are familiar with how to read a logarithm expression like that. Okay? And B and A has to be positive values. So you can never see any negatives here. After we go through some pattern, I'm going to go over what those are vocabulary wise. But let's see what the pattern is over here. Let's look at the this one. This one is the most obvious one. Okay, so I'm going to read it as log base 5 of 125 is equal to 3. And you should be thinking about what's the relationship between these numbers. What's the relationship between 5 and 125 and 3? I'll give you a hint. Something to do with the exponents. Some of you kind of see it. Okay, what do you see? Well, Mrs. Major, isn't 5 cubed equal to 125? Yes, it is. In other words, I multiply that 5 3 times. So 5 times 5 times 5 is equal to 125. Let's see a few more things over here. How do you read it? Log base 10 of 1000 equal to 3. What pattern do you see over here? Yeah, same thing as here, right? So if I do 10 raised to the third power is equal to 1000. 10 cubed is equal to 1000. Yeah, okay, let's keep going. What about here? 2 to the fourth power is equal to 16, right? 2 times 2 times 2 times 2 is equal to 16. So you should be able to go ahead and fill out all of them according to the pattern, right? So from now on, when you that little number right next to logarithm, that's gonna be the base, guys. Okay, so that 2 is gonna be the base, and this 4 is gonna be the exponent. So it's going to be base 2 to the exponent, fourth power equal to 16. This 16 is going to be called argument. Argument. Okay, so log base of the argument is equal to the exponent. All the answer of the logarithms are exponents. So the exponent is half, exponent is 2/3, exponent is -6. That's another thing you need to keep in mind. Okay, so the answer of whatever the logarithm is always going to be the exponent. Logarithm expression represents exponents. Okay, so when you convert all of this into the exponential form, you should see something like this. This is how you do it. I mean, I was going to say my 3-year-old can do it, but she probably can't do it. But maybe 3rd grade can do it. They know the pattern. There's a base, there's an exponent equal to the argument, so you can write it all how I wrote it here. Now I'm going to go over a few exponent rules that we might not remember. Okay, a few things. First, guys, what does it mean when your exponent is half? We kind of did that on scale 41. When your denominator of the exponent is 2, doesn't that mean that it's same as what? Square root of 36. Yeah, what's square root of 36? 6. You can see over there, half exponent of half is equal to square root. So a few patterns we already know of. What else do we see? Do you guys remember about negative exponents? Yeah, what does negative exponent means? You reciprocalize it. That's the weird word I made up, right? So what's 4 squared? 16. So it's going to be 1 over 16. Negative 3. 1 over 5 cubed is 125. And so on. What else do we see over here? Let me go over this one right here. Okay. So this is not the focus of this lesson, but we need to know how to do it to make the future lessons a little faster. So bear with me. Mrs. Major, how would you know that 27 raised to 2/3 power is equal to 9? Like, I can't do that on my head. Can you tell us how to do it? No problem. Okay, so how would I know what that is? Look at the number 27. 27 is, if I want to write 27 as an exponential form, how would you write it? Well, don't you know that 27 is 3 cubed? Yeah, right, okay. So 27 is 3 cubed raised to the 2/3 power. According to the exponent raised to the exponent, what do you do with these two numbers? You multiply. So what's 3 times 2/3? 2. So what's 3 squared? 9. That's where I got that 9 from. Okay. All right, let's do one more over here. This problem right here. 9, 9, 9. How do I write 9 as exponential form? 9 is 3 squared raised to the 5/2 power. Multiply exponent to the exponent. 3 to the 5th power. 3 to the 5th power is 243. So isn't it kind of cool? Yeah. Okay, so that's how you do it. Once again, how do you go from logarithm to exponential form? You read it as a log base of the argument equal to exponent, and then you write it as the base raised to the exponent 4 equal to the argument 16. That's how you go from one to the other. Okay, so based on studying those, make a conjecture as to know how one will find the value of log base b of a. So let's say log base b of a was, I don't know, pick a letter, y. Then we can convert this to exponential form. How would I do it? All right, what's the rule? The base raised to the, where's the exponent? Is a the exponent or y exponent? Y is the exponent equal to the argument a. So this, ladies and gentlemen, is the logarithm form. This is the exponential form. I mean, so they represent the same thing. It's just a different format. You see it? That's a logarithm format. That's the exponential format. Now, what am I going to do? Also, another thing you have to know about it is that logarithm and exponential forms are inverse of one another. Inverse of one another. What does inverse mean? You switch x and y and solve for y. So let me just quickly show you why that is the case. Okay, so I'm going to say y is equal to log base a of x. How do I find the inverse? You switch x and y. Can you guys see it? Oops. And solve for y, right? So how do I solve for y? You can't, so you need to convert to the exponential form. Where's the base? A. Where's the exponent? X is equal to y. Ta-da! So that's why these two are exponential form. I mean, these two are the inverse of one another. Okay, I just threw you a lot of information. Now make a conjecture about the value of the logarithm based on numerical relations between the values of the base and value of the argument of the logarithm. So if b is equal to a, then let's see, what does that mean? That means we have log base b of b, right? Because usually it's a log base b of a, but if a and b are the same thing, I can just write it like that. Then what does that mean? That means log base a of b of a is going to be 1. Why is that 1? Because if you think about it, if I let that equal to x and convert to the exponential form, base b, exponent, x is equal to argument b. What does that mean for exponent? Exponent is going to be 1, so 1. Okay? So when base and the arguments are the same, the value is going to be 1. What if the base is less than the argument? Let's see that. So log base b of a. What does that mean? I don't know what it is. I'm just gonna put the question mark. So let's convert to the exponential form. Base raised to the exponent equal to a. And b is less than a. So a is bigger than b. What does that mean for the exponent? That means the exponent is gonna be bigger than 1. I mean, I'll give you an example. If b is 5 and a is 25, what does that mean for exponent? Exponent is going to be 2. So any number bigger than 1 is going to give you that value. What if it's the other way? Log base b of a. So b is question mark equal to a. And if b is bigger than a, that means the whole logarithm value is going to be less than 1. That means your exponent is going to be less than 1. So any decimal like 0.5 or 0.1 or negative exponents, all the smaller numbers. Okay? Alright, let's keep it going. Now, a logarithm whose base is 10 is called common logarithm and is written as blah, 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 blah. Oh, sorry. Written as log base 10 of 100 is equal to log of 100. In other words, guys, when you do not see the base on the logarithm expression, assume that it's going to have a base of 10. What do I mean by that? All right, look at these expressions, guys. Where's the base? Where's the base? Where's the base? I don't see it. So when you don't see the base, that means your base is going to be 10. So I can just sneak it in if I want to. It will not hurt to write that 10 as a base if you want to, but you don't have to. So on your calculator, guys. Sorry, I should have told you need a calculator. If you look at that log button, find the log button. So I type it log, I don't know, 5. Notice that there is no base. So all your calculator always assume your base is going to be 10. So I type log 5. I get 0.698. Why would that be? I mean, it makes sense, right? Because so this means question mark. If I were to convert to the exponential form, 10 to the question mark is equal to 5. Notice your number got smaller. That means your exponent is going to be less than 1, like our conjecture that we wrote in the previous page. Right? If b is less than a, sorry, if b is greater than a, that means your exponent is going to be less than 1. There you go, less than 1. All right, now log of 100. Well, this one we actually don't even need a calculator. 10 to the what power gives me 100? Second power. Let's just verify that using our calculator. So log of 100, enter, I get 2. There you go. All right, next one, log of 115. Oops. I get 2.061, which makes sense because my argument is bigger than my exponent. Okay? All right, we're almost done. Based on your understanding of the value of the logarithm, what conclusion can you make about the values of the following logarithm? So I'm going to do the first one with you. All right, there's a logarithm expression. Find the value of the given logarithm if the value is not an integer, blah, blah, blah. Okay, well, I don't know what it is, so question mark. And I'm going to go ahead and convert to the exponential form. Base is 3, exponent is equal to question mark, equal to the argument 81. All right, 3 to the what power gives me 81? 3 times 3 times 9, 9 times 3 is 27, 20 times 3 is 81. I multiply 3 4 times, so answer is going to be 4. Given the expression, blah, 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 log base b of a, use the calculator to find the value of log of a over log of b. Okay, so with that expression, I'm going to do log of 81 over log of 3. Let's go ahead and plug that in our calculator. Log of 81, make sure you close the parentheses, divided by log of 3. Close the parentheses, I get 4. Interesting. You know what is about to come? Yeah. All right, so let's keep going. Equal to question mark, convert to the exponential form. 2 to the question mark is equal to 1 over 8. Notice, yeah, got reciprocalized. That means it has what type of exponent? Probably negative exponent. 2 to the what power gives me 8? Third power. So it asks me to find log of the argument 1, 8 over log of 2. So let's go ahead and type that in my calculator and see what happens. I would like you to do it along with me so you know how to type it in your calculator. I got answer of negative 3. All right, if I were you, well, I will do one more with you. Equal to question mark, convert to the exponential form. 2 to the question mark equal to 9. All right, there's a problem. Well, I don't know what exponent of 2 gives me answer of 9. So this is what you need to do. Find something that you already know about the base of 2, around 9. Okay, so let's see. 2 to the, isn't third power gives me answer of 8? Yeah. And what's bigger than 9 that you know of that has a base of 2? 2 to the fourth power have the answer of 16. Doesn't that mean that 2 to the question mark is going to be in between these two? Oh yeah, 9 is between 8 and 16. What does that mean for the question mark? Then question mark is going to be greater than 3, less than 4. So it's going to be in between 3 and 4. That's what we are doing for those problems that you don't know how to find them. So since that's our guess, let's go ahead and find what that is exactly. So log of the argument 9 over log of 2. Type it in your calculator. Log of 9 divided by log of 2. I get answer of 3.170. So it makes sense. It's going to be between 3 and 4. There it is. All right, pause your video. I really need you to try those 3 problems underneath it and come back and then we'll check it. Come on, please check, pause, and do it. Okay, so I trust that you guys did it. Was it too much trust? No. If you do, you should get the following answers. The log base 3 of 36 is between 3 and 4. Next one between 2 and 3. Next one between 4 and 5. Just for the reference, the last one is going to be, let's see, 3 to the 4th power is 81. 3 to the 5th power is 243. And since 105 is between these two, that's why it's going to be between 4 and 5. Now, what can you conclude about the value of log base b of a and log of a over log of b? They are the same thing. In fact, that's how you're going to plug it in your calculator to evaluate the logarithm expression. Okay, but remember, guys, your base goes in the denominator, log of base, the b, and the argument goes on the top. If you mess it up, you're messing up the whole problem. So make sure you know which one goes where. Cool. All right, guys. Thank you so much for paying attention. Your IP for the day is skill 44. The whole thing. Oh, yeah. The whole thing. And I don't think I'm going to give you any answer. I don't know. I haven't decided yet. But these are pretty straightforward. So number 1 through number 15. It should not take you that long. If you have any questions, feel free to email me or come to my office hour. Heron Kids, you saw it on Haiku. My office hour got moved to 5 to 6 p.m. So come if you need help, okay? All right, guys, have a good, well, I'm having a good night. So I'm going to go to sleep. Well, I'm not going to go to sleep. I'm going to go watch Netflix show. And you guys have a good rest of the day. Bye-bye.